Okay, guys, so welcome to BayTutors Intermediate Advanced Programming Camp, Day 2.
We're excited to have you guys here with us today, and we have a lot of interesting material prepared for you guys.
Okay, so the first thing we're going to do is we're actually going to be reviewing the worksheet from yesterday. So now Arnav will be sharing his screen and reviewing over the worksheet in depth.
All right, okay, so you guys were assigned this worksheet last week, and let's go over it in detail now. So last week we covered data structures and variables, and we kind of went into loops. So the first question was,
last night.
Sorry, okay. The first question is, what is the difference between declaring and initializing a variable? And so declaring a variable is kind of like you're setting the name and the type of the variable. So declaring a variable is setting the name and type of the variable. And initializing is kind of like you're actually setting a value and storing a value inside of that variable. So that's question one, and let's move on to question two, which asks which of the following is not a primitive data type. And last week we covered this. So integer is a primitive data type, character is also primitive, but string is not primitive. And string is actually an object, and we'll be talking about objects today. So the correct answer here is string. All right, so for question three, it asks what did the following typecast yield? And the first question, part A, asks, we're typecasting a character, capital Q, to an integer. So if we refer to our ASCII table, we can see that Q is over here, Q is over here, and then Q is actually 81. The integer value for Q, capital Q, is 81. So the correct answer to this would be 81. And then for part B, it asks to typecast 47 to a character, and again, referring to our ASCII table, if we look at the number 47, we see that it's actually a slash, so that would be the correct answer for this. Let me bold that. And for part C, it asks us to typecast a double to an integer. So like we talked about, when you're typecasting a double to an integer, you'll always round down, or we just ignore the decimal places. So this just typecast to 6. And when we're typecasting a double to an integer in part, and from an integer to a double in part D, we actually just convert it to a double and it becomes 5.0. All right, so for question 4, it asks, what does the following statement equate to? And this kind of integrated Boolean algebra. So we'll start by taking a look at the statement. So the first thing we'll be looking at is this statement over here. So it asks, is 4 less than or equal to 4? And since this is true, so this is true, and then the second statement in the OR is 3 greater than 9, and that's false. But since this is an OR, we prioritize the true, and this entire statement becomes true. But then since we have a not right in front of that, this entire thing becomes false. And since we have an and over here, we already know that this statement is false, so we can ignore this, because when you have one statement in an and that's false, then you know that the entire thing will be false. So this is actually false. And then now we're going to start taking a look at for loops. So for question 1, it basically loops from 0 to 10, inclusive of 10. And we're basically just squaring the number 0 to 10. So the answer here would be 0, 1, 4, 9, 16, 25, 36, 49, okay, 64, what's after that? Okay, sorry, 81, and then we get to 100. Since it's 10 inclusive, because of the less than or equal to 10, it's inclusive of 10, so we get to 100. And then for question 2, it asks, write the output of this. And so the first statement in our if is we typecast 3.14, which is a double to an integer. And when we typecast this, it actually converts to a 3. And then we're checking, is 3 not equal to 3? And that is false, or that is true. So then that is false. So then we go ahead and move on to the else if. And then we're saying, is true equal to false, which is false. But then we're doing not of false, which becomes true. So we actually just go ahead and print the else if statement. So we print else if. And then for the final question, it asks find the output of this code. And then it's basically just a while loop where we have our counter variable I, and then while the typecasting of this double to an integer is not equal to 4, we continue to print out an increment I. So if we start off, we know that so basically first we print I, and then we increment it to 1, and then we increment it to 1, and then we check, hey, is this typecasted not equal to 4? But since 3.59 always typecasts down to 3, it's never going to be 4. And this essentially just keeps repeating into a process where we have an infinite loop. So this is actually just an infinite loop, and we can just write that as our answer. So with that, that's the end of reviewing worksheet 1. And let's move on to the content for today.
Okay, yeah, thank you, Arnav. So now we will go ahead and begin. Oh, okay, I believe you have a question from Akshita. So she said, for question 3, there are only 3 opening parentheses, but there are 4 closing parentheses. Okay, yeah, so for that question, I think that was just an error on our part. So technically, if you did say there was an error because there was an insufficient number of parentheses, that would be correct in this case. But I think what we were just trying to just like convey through this loop was just that it would lead to an infinite loop. But in the case that in some of the worksheets that may come in the future, if there are any situations where there are like maybe extra parentheses, just state that there's an extra parenthesis, but just try evaluating the entire code statement as is, just to see, because like just to like get the gist of the content that we're trying to spread. Thank you for that question. Okay, so now we will go ahead and begin with our lesson for today. Okay, so today we will be starting off by going over some basic object-oriented programming concepts in Java. Then we'll be teaching you about classes, then moving into constructors, and finally concluding with methods in Java. So our first topic today is object-oriented programming concepts in Java.
All right, so object-oriented programming is actually a type of programming that represents everything or as an object. So each object has its own attributes or properties that are represented by variables in Java. And so as an analogy, we can use a house, and a house has several different parts in it, such as doors and windows. And doors and windows can be represented as objects in the greater picture of that house. And when we're looking at doors and windows, we can actually go ahead and think of them as an object in Java. And some attributes of those would be things such as the width or the height or the color. So if we look at this flowchart over here, we have a house as the bigger picture. And then within the house, we have all of these parts to it, which are represented as objects. And within the objects, we have variables such as color, the width, or the height. And there are many different like attributes to each object, but these are just a few. And that's kind of the like idea of object-oriented programming, where you can represent things as objects.
Okay, thank you, Arnav. So if you guys have any questions, I know that was really brief. We'll be actually expanding more upon that in the next couple of slides. But if you guys do have any questions, please feel free to say that in the chat right now. Okay, so we will move on to the next thing. So now we'll be talking about classes. So through these next couple of slides, you'll sort of understand how object-oriented programming sort of works. Yeah, so our next topic is classes. So what are classes in Java? So classes in Java are essentially like a blueprint from which the objects are created. So classes in Java are tend to have 3 sections in general. So they tend to have attributes, which are essentially the variables known as instance variables that describe the objects of the class. Then we have constructors, which are essentially methods that have the same name as the class. However, they're used to initialize the attributes of the class. Sorry, that should be saying attributes, not objects. And lastly, we have methods. And methods are essentially code that defines the actions that an object has that an object of this class can perform. So on the right, we have like a sample general class structure. So as you can see, this is a syntax for creating a class. It's public class, my class. And my class is the name and public is the access modifier. The access modifier is essentially just saying like, how can it be accessed? So like if it's public, it can be accessed by any other class, and so on. So, and as you can see, we have our attributes, constructors, and methods. So this is just like a general class structure, and we'll be expanding more upon each individual section in the next slide. So here's a more visual representation of like a class. So for example, if you were to take like a dog, right? Let's take a dog in general, and let's say we have a class called a dog. So we split it up into two sections, the attributes and the methods. The constructor we did not include in this flowchart for a certain reason, which we'll get to later. So let's take a look at the attributes point of this chart. So if we follow along, we see that the attributes is a breed, a name, and an age. So essentially the qualities that a dog has, right? The attributes of a dog. So a dog tends to have a breed, a name, and a certain age. And these are just a couple attributes. You can always have more that you can add to a dog, such as its gender, and so on. And on the right, we have methods that are associated with this dog class. And the methods are essentially like an add age method and a get breed method. So we'll be expanding more upon methods in the next couple of slides. However, just like a quick gist, so the add age method would essentially allow you to add to the age. So this age attribute, if you were to call this method, it would increase the age of the dog. And if you were to call the get breed method, it would give you the breed of the dog. So this is just a general class structure. For example, if we were to look at like a dog class, and as you can see, all the attributes are going to be initialized within the constructor, which we'll be getting to in a little bit. So now we'll start talking about constructors.
All right, so constructors basically initialize all of the attributes in the class. And when creating and initializing an object in the main method, and we'll talk about the main method a bit later, but when basically initializing an object, we use the constructor to do so. And looking at the general format for a constructor, we basically just have public, so that public is basically the access modifier, which means we can access the constructor from other classes. And then following the public keyword, we have the name of the class, which is just the name of the class. And then often the constructor has parameters in it, and these include values for what you want to initialize the attributes to. So here's an example of some attributes in the constructor. So this class kind of includes two attributes. It includes the age of a person and their name. And then looking at the constructor, it's we have the header for the constructor as public, and then person as that is class name. And then we initialize age to 15 and the name to Nathan. So this is what we call a default constructor, and the object has set and standard attribute values, and the user cannot input any like custom parameters. So this default constructor doesn't, like, we don't pass in any parameters into it, but in the next slide, we'll take a look at a constructor where we do actually pass in parameters into it.
Yeah, and another thing to keep in note is that the age and the name, as you can see over here, they are private. I think as Arnav mentioned, this is just so that other classes cannot access them. And as you can see, these are called instance variables because they're not initialized. As you can see, it says this private int age semicolon. So you're not actually setting the age to a certain value. And instead of this constructor, you're actually initializing the age to 15 or name to Nathan Coatney. Essentially what it's doing is that when you run your program, it's actually running the constructor, and then the constructor is actually setting the age to 15, setting the name to Nathan Coatney, and then it's going to be moving on with the rest of the code. So now we'll go and take a look at the next slide.
All right, so in the previous slide, we talked about default constructors, but there are more types of constructors where you can actually input parameters into them and then set the blank attributes into the class to something custom. And before we talk about that, let's talk about the this keyword. So basically, the this keyword refers to the object itself. And essentially, when we use it, Java points to the specific instance of the object. And what that basically means is, like, when you create an object or like a class, for example, you can have multiple of that object, but when you use this keyword, you're referring to that specific instance of the object. And that basically allows us to refer to something specific, and that allows us to like not have any confusion with what we're referring to. And additionally, a class can have multiple constructors, as long as the parameters inside of the constructors differ. So you can't have two constructors with the same parameters, but you can have like a default constructor and then a constructor with different types of parameters in a class, and that's totally okay. So looking at another example of a constructor, we have, similar to the last example, we have a private integer is age and the private string is name. And then in this constructor, we actually pass in parameters as like custom things. So we pass in int age and string name. And then we do this.age equals to age. So basically, when we say this.age, we're referring to the private int age. And then when we just say age, we're actually setting the age, like the private int age, to the age that we passed in. And that's the same thing with name, where we basically set the value, like the field variable of the attribute, to the thing that we passed in. So whenever we create the object with this type of constructor, we can pass in custom values, and the attributes basically like are initialized with the constructor.
Yeah, and as Arnav mentioned about this keyword, it refers to the current class instance variable. So it refers to the private int age, and the name refers to the private string name. But in the case that you would not like to go through this confusion of saying like this.age is equal to age, you can always rename the integer age, like the parameters of the constructor. You can call it like int like person age, or int or string person name inside the constructor parameters. So you can always rename those to something that you would like. That way, you would have to, that would sort of like reduce some confusion when you're writing your code. Yeah.
All right, and then finally, we can talk about calling constructors. And when creating an object, we actually do so with a constructor. And note that even though we don't like, sometimes we don't even have to like write out the constructor within the class, and Java will actually not throw us an error, because whenever we don't write a constructor for an object, Java actually creates like a default constructor, and it's basically just a blank constructor that allows us to initialize the object without an error. And when we're declaring and initializing an object, it's actually very similar to declaring and initializing a primitive variable with a few differences. So taking a look at it step by step, the first step is we declare what type of object it is. And essentially, this is the name of the class of the object, followed by the name of the variable that we want to name it to. So after we do that, we obviously add the equal sign, as we do with primitive data types. And then to the right of the equal sign, we actually use another keyword, which is called the new keyword. And this is essential to creating any object. And after we call the new keyword, we pass in any parameters, or if it's just a default constructor, we don't pass in anything, but we pass in any parameters that may be needed to like properly initialize that object. So for our first example, we initialize person P1 as a new person, where their age is 16 and their name is Joe. And on the previous slide, we looked at like a constructor where we pass in parameters. Yeah, so on this slide, we actually can see the parameters being passed. Like these are the parameters in order where we pass in age and name. And going back to the slide, we can see that we just did just that. So we initialized it correctly. And for the second constructor type, we set it to a person P2 as a new person, where we just actually have like a default constructor. And if we take a look at it, within the class, we initialize it to like a set standard value where the age is 15 and the name is Nathan Cohen. So I think one important thing to take away from that is that you have to make sure that we include the new keyword, as without it, we'll be thrown an error. So the new keyword is basically really essential to creating an object.
Okay. So just to clear up stuff again, so this person P1 is the name of the object, and P1 is actually a different object than P2, even though they're so P1 is a different object than P2, and P1's age value is going to be 16, and P1's name value is going to be Joe, whereas P2's age value, if you go back, let's go back to here, P2's age value is using this constructor, which has no parameters, and their age value is going to be 15, their name's going to be Nathan. So that's just to clear up any doubts if you have any. Okay, so now we'll be moving on to methods. So methods, as I mentioned before, are just the actions that an object can perform. And unlike constructors, methods contain something called a return type. And methods can have any name they want. They don't have to have, methods don't have the same name as your class, obviously, only the constructors do. So methods can have any name you want, and you generally want to make your name of the method relevant to what the method does, sort of like an action, right? And so now going back, so methods contain a return type, and a return type is essentially the kind of information, the type of information that the method sends back to the caller of the method. So if you were to look, like a pretty good example is like a function of x. So if you guys are in algebra, you guys might understand that like if we were to have a function such as f of x is equal to 2x, and we pass in f of 5, right? Let's say, so essentially the x is your parameter, right? You have an int x. And if we pass in 5, right, as our value, we get 10 as our output, right? Since f of 5 is 10, since 2 times 5 is 10. And 10 is what's returned back to us, right? Because 10 is what's given back as a result of passing in 5. And since 10 is an integer, right? If you guys dial back to yesterday, 10 is an integer. Since it's a whole number, then technically the return type for f of x equals 2x, right? That method would be an integer. So in addition to just having a return type, methods also contain an access modifier, as we mentioned before, similar to like a class and variables. They also contain a method name as well as a parameter list. So as you can see, the access modifier should be quite familiar to you guys at this point. It's a public method, meaning that it can be accessed by any other class. The next thing you say is the int, right? So the int is essentially the return type. So you say public int. So since this will be returning an integer, your second thing will be an int, which is your return type. This can also be a string, a double, a boolean, whatever it is that you'll be returning. Next comes the name of the method. So I call this twice, since we'll be returning twice of the value that's inputted. You can call it anything else. You can call it like function or function of x. You can call it whatever you want. And after that, we put 2 parentheses. And then if we want to have a parameter, you can put your parameter in there along with its corresponding data type. So here I passed in the parameter int x, since that is what, when I call the method, I'll be passing in a value that will act as x. And over here inside the method, we say int product. We create a new integer variable. We initialize that to 2 times of x, or 2 times of what is inputted. And then we're going to go ahead and return product. And product is of type integer, as you can see here. So therefore, it corresponds with our return type. So therefore, we are returning an integer as it comes in. So in full-fledged, if you pass in, let's say we make a call, say twice of 3. Twice of 3 would make, so basically if you were to pass twice of 3, you say int product is equal to 2 times 3, which is 6. Therefore, it'll return 6. So that's sort of how like a method sort of works just in general. And now we'll be going into different types of methods that exist. So
wait, just a quick thing, going back to the previous slide, whenever you're naming a method, it's similar rule, like naming rule is to naming a variable, where you can't have spaces or like special characters. You can have like numbers in uppercase and lowercase letters, but you can't have a space between the name.
Yeah, correct. Yeah, so that's correct. So make sure you guys just keep that same syntax of when you're naming a method. Okay, so now we'll be going over types of methods, since there are many different types of methods. So the first type of method, it's generalized into 2 categories primarily, which are setters and getters. And sort of by the name, you should sort of understand what the method does in terms of its action. So the setter methods essentially set or change a value of an attribute, or like your instance variable. So for example, suppose like we were to go back to our dog class all the way, oh, sorry, I'm going forward. If we were to go back to our dog class over here, suppose we had a setter method over here, a setter method somewhere over here that said set name or change name. And if we call that name and we pass in like a new name to that method, it would go ahead and change this instance variable to that new name. So for example, suppose we said set the name to Sparky. So then suppose the dog was initialized with the name like Rock or something. Then when we call the set method, say like set name to Sparky, it would go ahead and change the instance variable's name to Sparky, and so on. So yeah, so that's sort of how a setter method works. Let's actually go back. Oh no, second, sorry. All right, there we go. Okay, so and usually they do take in a parameter, as I mentioned. So if you want to set or change a certain attribute value, you want to put in like what it is that you want to change, right? Or what is it that you want to change it to? So for example, if you wanted to change the dog's age, then you would sort of create a method that says like change dog age, and then you'd have like an integer parameter such as like the new age that you want to change it to, and just do like that. So usually setters usually take in a parameter value. Either it can be a string, boolean, whatever it is that's intended for, and it's usually used as a helper method. And the reason I say helper method here is, suppose you have your constructor, and suppose you have a lot of attributes to your class, like maybe something more complex than a dog, right? Something that usually has a lot of attributes, like for example, a house, right? A house has a lot of attributes. And in your constructor, like suppose you didn't want to like set all your values, all your attributes in the constructor, because that'd just be too big of a parameter list in your constructor. Then you could use a setter method later on, maybe for something that's not as important, like maybe your temperature or something. You want to set your temperature in the house or something else. You could actually have it as a setter method. So the temperature would still be an instance variable, but you wouldn't initialize that instance variable in your constructor. Instead, you would initialize that instance variable in a setter method called like set temperature. So that's why it's called a helper method, because it can be used in addition to like a constructor or something. Okay, I think we have a couple of questions. Okay, so Angshu said, so the setter method changes the attributes initialized in the constructor. Yes. Yeah, Arnav answered that. Yes, it does change the value, and the old value is discarded. Correct. Yeah, so just to research this question, your attributes will be changed based on your setter method, and it's up to you. Like in your setter method, you can set your attribute value to something else, so that would essentially change your attribute value. And its return type is usually void. So a void return type essentially means it does not return anything. And that's because you're just changing a parameter value, but you're not giving anything back to the user, right? You're just changing something, but you're not giving anything back. So essentially, your return type would be called void. And void would be a return type. Instead of being like int, string, or boolean, you'd say void. The next type of method is a getter method. Yeah, go ahead.
Just one thing to talk about void is that even if you don't return anything, it is very important to have that void keyword, because otherwise, if you don't have a return type, Java will view it as a constructor and you'll be thrown an error.
Up. Hello? Okay, yeah, so I think what he meant to say was, even if you do not have, even if you don't intend to return anything, it's important to have that void keyword there. Okay, the next type of method is a getter method. So the getter method essentially gives you, right? It's a getter. It allows you to get the value of a certain attribute or a certain variable inside your class. And getter methods don't usually take in parameters unless, like in certain cases, it might. So an example of a getter method, if we navigate back to that thing again, for example, I created a getter method called getBreed. So essentially, in this getBreed, if I were to call the getBreed method, it would essentially give me back, it would return to me the breed of the dog, the current breed of the dog. Like suppose I'd set the breed to something else, and then I say getBreed, it would return me the current breed of the dog. So essentially, it would return me a value. And therefore, since it will give me back a value, it will have a return type because it's going to return you something. And you have to make sure that that return type is of the data type that you're returning. So like if you're going to return the name of someone, make sure that your return type is a string. And if you're going to return an age, make sure that your return type is an age, and so on. So getters are generally pretty simple to make. If you want to say get age, you just say return the age, and so on. So down here, I have an example of like a fully fledged creation of an object, the constructor, as well as the methods that are used. So, oh, okay. Angshu asked another question. So is there any specific syntax for a setter? Or can you just name the method anything? Yeah, so you can name the method anything. I mean, like if you're gonna create a setter method, it's ideal to name it something like set name or set age. But in the end, you won't get an error if you name it something else. But in ideal, if you want to make your programming clean, then I recommend that you give it a name that sort of correlates to what your method's actually giving back. And that goes with almost any method that you're going to create. As I mentioned before, just make sure that your method name is sort of relevant to what you're going to give back, or else like it doesn't really make sense that you're making a method that does something else, but you gave it a different name. Okay, so now moving back here. So as you can see here, we're creating an object of the dog class. So we say dog. My dog is the name of the object that we're creating, and we're saying is equal to a new dog, Labrador Spark 6. So if we actually go back, let's go back to this thing. So we have 3 attributes over here, right? And these are going to be in our constructor. So we have a breed, name, and age. So in this order, right? So these are essentially also the 3 parameters of our constructor. So if you look back here, it'll make more sense now. We say dog, create a new dog, and in our constructor over here, we're saying it's of type Labrador, is its breed, its name is Spark, and its age is 6. And then we're going to go down here, and we're going to say my dog.getBreed. And what essentially this would do is it would return Labrador, right? Since that's the breed as a current dog. And then if we create another method called change name, sort of like a setter method, right? We'd say my dog.change name, parentheses, quotes, Joe. So essentially what this would do is it would change Spark, right? The name of the dog, it would change it to Joe. So for example, if you were to go back after this line, you would say my dog.get name, it would return to you Joe, and no longer, it would not return Spark to you, it would return to you Joe. This is because the attribute value would have been changed when you called the .change name method. Okay, so that was just sort of like a brief overview of methods in general. And now we'll be going over something called the main method. I'm sure most of you are familiar with this. So the main method is essentially the entry point of a Java application. And it's essentially the method that is called when you execute/run your project. So you're like, okay, so a lot of people might have the question, right? So I create these classes, I create these objects, but like, how do I run them, right? How does the compiler know like where I'm creating these objects? So essentially, this object, you see this whole thing over here, the my dog, blah, 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 blah. All this stuff would essentially be, you would essentially put all of that inside of your main method. And your main method, there's only one main method per Java app, so that the runtime can execute this method, and it can also find that one main method. So you don't want to create a method called main that is not a main method, because then that could confuse the compiler and it would do something else. So make sure that you only have one main method per Java project that you're creating. So with a main method, it comes with a certain signature, right? A certain syntax, and that is this: public static void main string array args. This might seem kind of weird to you at first, but this is just sort of how it has to be. It's a fixed signature. It cannot be changed. Each one of these elements has to be included. The public, the static, the void, the main, the string array, and the arguments, they all have to be included, or else then you'll not be able to run your program. So the public part of this is just so that the Java runtime can execute this method, since public is available to everything. It's not private. The static is just so that the JVM can load the class into a memory and then call the main method. So we'll be going into static methods I think this Friday. So this next class we'll be going over static methods more in depth. And as you can see, the void is the return type. And this is because the main method does not return anything. It just runs stuff. So it is a void method. Main is the name of the method. And the string array is essentially that it accepts a single argument of type string array. And don't worry about it at all. It's just part of the command line argument. So there's no need for you to worry about any of this. And just in general, don't worry too much about the main method. Like it's like knowing all of this information that, oh, this is what this is, and all that stuff. The main idea just take out of this is that if you want to run your program and you want to run like certain objects and stuff, make sure you put all of that code inside of this main method, like when you're creating the objects and stuff. Hey, Arnav, do you have anything to add?
Yeah, so just like Nandi said, yeah, it's very important to have a main method, and without a main method, your program will not run because there's nothing being called or nothing to there's nothing telling Java hey, run this. So you need a main method.
Yeah. So essentially, this is where you're going to be putting all the stuff that you would like to run. Okay. So that was like a really quick, but I think really informative overview of just like object-oriented programming concepts in general. So now we'll be moving on to a Eclipse demo where we'll be giving a live demo of just creating a new Java project in Eclipse, then creating a package, creating a class, and then creating a main class, and just sort of working this whole dog class I talked about. We'll just be implementing that right now. So if you guys would like to follow along, if you guys do have Eclipse, please feel free to open it up right now. Or if you guys do not have Eclipse, please open up Replit. going to repl.it, and then you guys can create a new Java a text editor there and follow along as well. Okay, so I think we have more questions. So Angshu said, oh yeah, what's the return type for a setter method that changes a string attribute? What is the return type? Oh yeah, so Angshu, the return type for a setter method that changes a string attribute. Once again, setter methods do not have return types, since they just simply set a method and will not return. So for setter methods, your return type would be void. So there's no need to have a string or anything, returning nothing.
Yeah, and then in case you meant getter method, in case you did mean getter method instead of setter, it's basically the return type would be just like string where the S is capitalized. So just like any other type of return type, it like goes with string as well.
Yeah. Okay. So if you guys, yeah. So if you guys are ready, or if you guys, are you guys going to be following along? Please feel free to unmute your mic and let me know. Sorry. Okay. Okay. So I'll go and start the Eclipse demo. You guys can feel free to follow along. So before we get started, I just like to go over. So first thing we're going to do is create a new Java project, just sort of where all our code and classes and everything will be inside. Then we'll create a Java package within the class to sort of organize all our classes within the project, to sort of organize all our Java classes. So package is essentially like a package, right? As you can think about it, just like an area where all your classes are organized. And then we're going to create a class within that package, define its attributes, create a constructor, define methods, and then we're going to go and create a main class, which will have our main method. And then we're going to run the program and see how it all works. Okay, so I'm going to go ahead and start up Eclipse. Okay, so right now I'm in Eclipse. And the first thing to create your own Java project is you're going to go ahead and navigate over to your Package Explorer, or on your or if you go to File, you can also click on New. And you're going to go and click New Java Project. So you're going to go to File, New Java Project. And once it opens up, you can go ahead and create a project name. So for example, I'm just going to go and call this BayTutors Summer 2020 Demos. Okay, that's the project name. You can go ahead and configure this all on your own. I used to use an execution environment, JRE, with the specific version, mine is 12. And then click create separate folders for sources and class files. And once you have all of that, you can go ahead and click finish. This will go ahead and create your Java project. Now it's creating the project. And when it says create module info, you can go ahead and click don't create, as it is not necessary. You can go and click don't create. And as you can see over here, our Java project has been created. So now we're going to go and open it up. And then we're going to go ahead and right click over here. Go ahead and right click over there and click new package. So go ahead and right click on your project folder and click new and click project. Sorry, and then click package. And then we can go ahead and create a name for this package. Let's go and call it classes. Okay. And since this package will be containing all our classes for this project. So once we go and do that, just go and click finish after you give a name to your package. And then as you can see, a classes package has been created down here. Then we're going to go and click on that classes package, right click, click new, and then we're going to go ahead and create a class. It should be in green. So go and click on your classes package, right click on it, click new, and click class. Once you click on a class, you can go and see that it's in your source folder inside your BayTutors Summer 2020 Demos project, inside your classes package, and you're going to go and give it a name. So I'm going to go and call this dog, since it's going to be our dog class. You can go and make it a public, and then type, you can go and select inherited abstract methods, but do not select the public static void main string array args thing. Just make sure you just have this exact orientation. Once you have this, we can go and click finish.
Yeah, and
now yeah, go ahead.
One thing to note about packages is that packages are kind of like, they just help you organize all of your classes, because when you're writing a program that has like like a lot of classes, like 20 classes, for example, it's easier to often organize them in different packages. So packages are just like a tool that helps you organize your code in a like simpler form.
Yeah. Okay, so now that we have our class, as you can see here, it's within the classes package. It's called dog.java. So now, as you can see, this should look quite familiar to. It says package classes public class dog. So this is our class. So now within this curly braces, we're going to go ahead and define our three things. So if you guys remember from the beginning, we stated that classes have three main sections, right? The first one are your attributes. Second one is your constructor. And your third one is going to be your methods. All right, so these are your three sections to a class. So let's start off by creating our attributes. So in the dog classes, as we mentioned, a dog might have many attributes. So for example, it might have a breed, right? And a breed in this case is going to be a name, right? Like either a Labrador or a Golden Retriever and so on. So we can go, and that's going to be a string, right? Since it's a name, like for example, let's say Labrador is a string. So we're going to say string breed. This is our first attribute. It's an instance variable, so we do not initialize it. We just close it off with a semicolon and make sure that these instance variables are private for now. Next, we're going to create another instance variable, which will be the name of the dog. So say private, and name is also a string, right? Since it's a string, name. And then the last thing we're going to have for this dog is its age, and age is an integer. So as you can see, we have our three attributes here for this class. Private string breed, the breed of the dog, the name of the dog, as well as the age of the dog. Oh, and if all you guys do have any questions as we're moving along with this, please feel free to type in the chat so that we can get back to you. Okay, so now we making our constructor. So as mentioned before, the constructor will have the same name as the class. So we're going to go and say public dog, right? And that's the name of the class. And we're going to have some parameter values for this constructor, right? So we want to initialize all these attributes, right? So ideally, we could just have a constructor like this, like a default constructor where we just say breed, say this dot breed, just to make it more specific, right? This dot breed refers to this variable over here, right? The local class variable. This dot breed is let's just say it's a lab. And we can say this dot name is equal to Rocky, and then we can say this dot age is equal to 3. So what this default constructor does is when the object dog is created without any parameters, it'll automatically initialize this dog class, these dog class variables, right? These attributes. It'll automatically initialize the breed to a lab, the name to Rocky, and the age to 3. But what if we wanted the user to create his own dog, right? What if he wanted to make his own dog with its own breed, its own name, its own age? So then we can give the user some more customization by giving some parameters to this constructor. So let's go and make some parameters. So first, let's make our first parameter, which will be the dog breed once again. So we'll say string breed. Okay. Next up, we can have a string name, and then we can have our int age. Okay, and as you can see, we have our second constructor, right? And the reason it's not giving us an error is because we have different parameter types. Suppose I were to do the same thing over here and do the same thing over here. Then, oh, sorry. If I were to do the same thing over here, then it would give me an error. And that's because we cannot have two constructors with the same parameter types. So we have to ensure that we have the same parameter types. So that we have different parameter types for each one of our constructors. So now inside of here, let's go ahead and initialize our instance variables in the case that the user would pick this constructor over the other one. So now we'll say this.breed is equal to breed. This.name is equal to name. This.age is equal to age. So as you can see here, we're using this keyword once again to refer to these attributes, and then this breed value is actually the parameter value. But if you don't want to get into this confusion, we can always call this dog breed, right? dog name, and dog age. So now we can go and call this dog breed, dog name, and dog age. And then we would not, we don't necessarily require this keyword anymore. Okay, so, okay, I think we have a question. Will this work in Replit or it'll work in Replit? In Replit, I'm not sure if you can create packages or anything, but you can just write this class down. You can just create a new Java class in Replit and do this as well. Yeah. Okay, so now that we have this, we've defined our two constructors. One is the default constructor, right? This is a default constructor, and this is let's call it our custom constructor. So now that we have our default, both our constructors done, let's move on to our methods, right? The third section of a class. So here, let's say we want to create 3 to 4 methods. So the first method, let's say it's a setter method, right? So as you know, setter methods do not have a return type. So let's just go and create a public setter method. Let's say public void. Let's say we want to change his name. So we'll just call it change name. And to change his name, we have to give a value, right, to change it to. So let's say the new name, let's call it string new name. And inside this method, we would like to change his name to something else, right? So then all we have to do is we have to say this dot name, right? We're referring to this attribute. We're going to set that equal to the new name. So what this method does is it's setting this name variable, right? This name attribute to the new name parameter, to the value of the new name parameter. Next up, let's create a getter method called public. So getter methods return something to us. We have to have a return type. So let's go and call this, let's make a getter method that returns the breed. So the breed is a string, as you can see here, the string breed. So our return type will have to be a string. We'll say public string get breed. And obviously we do not need to have a parameter here since we're not going to give them anything. We're just going to get something back. All we're going to do is we're going to say return, let's go and return the breed. So let's say return this dot breed. And what this does is it's just when we call this method, it's going to return the breed back to us. Next up, let's make another let's make another getter method that returns the name. So the public string get name is similar to the previous one. Since name is also a string, we have a string as a return type. So we're going to say return this dot name. And lastly, no, actually, next let's create a getter method that returns the age, right? Oh, sorry. And as you can see, age is an integer, so we're going to make public int, right? Get age. Once again, no parameters since it's a getter method. Then we're going to say return this dot age. And lastly, let's go ahead and create a setter method. It says public void add age. And this time let's pass in a parameter. Let's say int number of years. So let's say we want to age our dog like 2 years or 3 years or 1 year. We're going to go and pass how many years we want to age him by in this parameter. And then we're going to say, we're going to go and change our age. So we'll say this dot age plus equal num years. And then, so what this does is it's adding num years to our age. So it's populating this age, this age variable by num years. So suppose our age is equal to 3, and we pass in add age 5. Then what's going to do? It's going to do 3 plus 5. That's equal to 8. So then our new age for the dog will be 8.
Yeah, and
so
again,
with this, yeah, go ahead.
Again, plus equals thing is basically just like a shortcut, so you don't have to type, like for example, you don't have to do like age equals age plus num years. So like we can eliminate all that unnecessary like stuff with just by using plus equals.
Yeah, another way of doing this could be like this dot age, as Arnav mentioned, is equal to this dot age plus num years. Right? That's another way of doing this, but as you can see, this is more concise. It's easier to read, so you can go ahead and comment this out. All right. So now with this, we have completed our dog class. As you can see, we have our attributes, right? Our instance variables, our constructors, and then our methods over here. Okay, so now we'll go ahead and, so now we've created all of this stuff, but how do we test out this class, right? How do we test all these methods? So we can do that by creating a main class. So we're gonna go ahead, click on our package once again, click on new, click on class, and then let's go and call the class main. And now when you're making this class, make sure you click on this little button down here that says public static void main. And this is essentially, it's gonna create this new class already predefined with this main method included that we talked about earlier. So now when we click finish, you will see that, oh, over here, we have our main method, right? The public static void main string array args. So now what we're gonna do here is now we can go ahead and create objects of our class within this main method. So what we're gonna do, let's go and create an object. We'll create two objects, one that uses the default constructor and one that uses the customized constructor. First, let's say dog. Let's say my dog 1 is equal to a new dog. And this time, as you can see, we don't have to put any parameters since we're just referring to the default constructor, which does not take any parameters. Next, let's create a second object. Let's say dog my dog 2. We can set this equal to a new dog. But this time, let's just go and use a parameter list. So let's say our breed should be a golden retriever, right? Let's say his name is going to be Bob, and his age, let's say his age is going to be 5. So as you can see here, we have created two objects, right? Two objects. Objects are essentially an instance of the class. So essentially, we've created two instances of the dog class over here. Okay, and one of them we use a custom constructor, the other one we use the default constructor. So now let's go ahead and let's go and print out by using the system out of print line. Let's go ahead and print out the names, the name of our first my dog 1, which uses the default constructor. So let's go and say my dog 1, and the way you actually let's do this. The way you call a method is you say the name of the object, my dog 1, the name of the object, dot, as you can see, we have a list of all the methods we can use, and we're going to say dot get, let's get his name. So what this does is it'll return his name to us. And now let's go and print out this value. Let's go and embed this within a print statement. So we'll say print line and print out the statement. So now, as you can see, if we go and print out his name, we will get Rocky. And the reason why is this one uses the default constructor, and as you can see, in our default constructor, we have his name set to Rocky. And if you want to make this more organized in your print statement, you can just go and say dog 1 name. Just make a print statement like that, just to make it a little bit nicer. So now, if we print it out, it'll say dog 1 name is Rocky. And similarly, we can just print out everything else about him, about this dog 1, all of his information. So let's say dog 1. Let's go and get his breed, and then let's go ahead and get his age. So now let's say dog 1 breed and dog 1 age. So now if we're going to print this out, we'll go and see that his name is Rocky, his breed is lab, and his age is 3. And if you go back to your class, we say that his breed is lab, his name is Rocky, and his age is 3. So both the information corresponds, and that is because we've used a default constructor. So now let's go and start tampering with our second dog. So let's go and copy down these statements. And now it's going to change the dog 2 name. And then let's go ahead and say my dog 2.get name, my dog 2.get breed, my dog 2.get age. So now the methods pertain to any object in the dog class. And now we're just getting the name, the breed, and the age of the dog. I'm sorry, yeah, so it's 5 o'clock, but if you guys can stick with me for a little bit, we're just going to complete this small tutorial, and then we will end today's session. So now that we have this, let's go and run it. As you can see, starting off here, we say dog 2, his name is Bob, his breed is golden retriever, and his age is 5. And this is because over here, as we see, his name is golden retriever, name is Bob, age is 5. So now let's go and test out some of the setter methods. Let me actually add a line here to make it a little bit more neater. All right. So now let's go and test out our setter method. So let's go and print out. So let's go and call setter method. So let's say my dog 2 dot. Let's go and change his name to a new name. So let's say his new name is going to be Flash. Okay. Let's go change his age. So my dog 2 dot add age. Let's go change. Let's change his age by 2 years. So now his current age is 5. It's going to change his age by 2 years. So it's going to fast forward 2 years ahead. Now his age will be 7. And then, yeah, so I believe we only had 2 setters, change name and add age. So now after making these changes, let's go and print out his information once again, right? So now let's go and print out his information once again. So here, now we're going to do the same thing. We're going to still print out his name, his breed, his age after this update. So let's see what his name, breed, age after the update is. So as you can see, name Rocky Lab 3, Bob Golden Retriever 5, and let's say after update here. And after the update, his new name is Flash. He still maintains the same breed. His new age is 7. So as you guys can see, that is sort of how object-oriented programming works in Java. So today we basically learned about the entire class, how to create classes. We learned about how to create objects, and so on. We learned about methods. So we created 5 methods over here, two setters and 3 getters. And we were able to use the main method over here to sort of test out our stuff and see the final results. So as you can see, these are our final results of this class. So yeah, so that's it. So now I'll go back to our slides. Yeah, so today, a quick summary of what we did today. So we covered just object-oriented programming in general, and just some important things about classes, objects, and methods, and so on. So when designing a class, something to keep in mind is that we must have attributes, a constructor, and methods. As Arnav mentioned, you do not have to have a constructor since Java will create one on default, but it's recommended to have a constructor if you'd like to have some more customization to your class. And methods, and we also learned about how objects are an instance of a class and how you can utilize the main method in which you can create your objects and test them out and test out your entire program. So yeah, thank you guys so much for tuning into BayTutors Day 2 of intermediate programming in Java.
And again, there's a worksheet for today as well.
So here is our worksheet. As you can see, you can access the worksheet at tinyurl.com/intermediate-worksheet2. So you can go and take your time to do that right now and submit it at the usual submission link. Okay, so once again, thank you guys so much for coming to our second session of BayTutors Intermediate/Advanced Programming. And we look forward to Day 3 with all of you.